Here are the pertinent formula for a projectile. In this activity, the objectives are the following. First, to measure the acceleration due to gravity and determine the velocity of a projectile just before it hits the ground. Second, to determine how the angle of projection affects the motion of the projectile. And third, to determine how air drag affects the motion of the projectile. The following materials will be needed and will be introduced accordingly. Part A is the freely falling body and the projectile. We will be using the projectile launcher. As you can see, this is the diagram of our projectile launcher. Notice that it has two spots here where you can put two marbles that will serve as the freely falling body and a projectile. Here in our launcher, there is a lever at the side, and once this lever is pushed downwards, the mechanism here is to dislodge one marble, which we call as marble A, thus prompting its motion directly downwards. So marble A is our freely falling body. At the same time, this lever at the center of our launcher will hit the marble placed in the side, which will then launch a projectile. And this marble will be called marble B. Here's the actual photo of our projectile launcher. Supposedly, there is a table clamp to lock in our launcher at the edge of the table. However, since this experiment was done at home, we did a bit of improvisation and instead secured our launcher via scotch tape. Now we set our projectile launcher at the edge of a cabinet which is not so high. Again, we call marble A, which falls down vertically as our freely falling body, and marble B is the one which is launched as a projectile. The first part of this experiment is to record the height of our launcher in meters with respect to the ground. Here are the materials that we are going to need. Aside from the projectile launcher, we need a meter stick, some scotch tape, two marbles, your scissors, and a carbon paper. The first thing is to note the approximate places where the marbles strike the floor. On each of these places, lay the carbon paper over the bond paper, and we tape the edges of the bond paper on the floor so that they won't move when hit by the marbles. Now we release the two marbles from our launcher and observe whether both marbles strike the floor at the same time. Then we measure the corresponding x, or the horizontal distance covered, and the time for marble A to hit the floor. Do 3 trials and record the data in the worksheet. This is the actual photograph of the bond paper with carbon paper markings signifying where the marble B hits our floor. And here we put our meter stick to determine the horizontal distance covered by marble B. This is the full data of the experiment A. Notice that while I perform the experiment, a helpmate also recorded the time using stopwatch, and this is the corresponding time per trial. Record this data in your activity worksheet. In the second part of our experiment, we are going to transfer our projectile launcher into a higher place. This time we put it on top of a table which the height does not exceed 1 meter. Record this height in meters. We perform the same steps as the first setup, taking 3 trials and taking note of the position and time per trial. Here is the video of the launching. And here is the data for the 3 trials. Record this data in your activity worksheets and answer the questions found in your worksheets. In Part B, a closer look on projectile motion, we are going to use our PHY simulator. First, we open this link on your browser. Then, we set the height at which the projectile is launched to 10 meters, the velocity to 5 meters per second, the diameter of the cannonball at 0.8 meter, the mass of the cannonball at 5 kilograms, the drag coefficient at 0.47, and the angle of launching to 30 degrees in your simulation. Then play the simulation and record the horizontal distance covered by the cannonball upon hitting the ground, which is signified by y is equal to 0, and the time of flight in the absence of air drag. We perform step 3 again, but increase the velocity to 10 meters per second, 15 meters per second, 20 meters per second, and 25 meters per second. We record the corresponding x and t in Table 2. Then we perform steps 2 to 4, this time with the presence of air drag. Again, record your observations in Table 2. Afterwards, we set the height at which the projectile is launched to 10 meters, the velocity to 10 meters per second, the diameter of the cannonball at 0.8 meter, the mass of the cannonball at 5 kilograms, the drag coefficient at 0.47, angle of launching to 30 degrees in your simulation. Now, vary the angle from 30, 40, 50, 60, and 70 degrees without air drag, and record the corresponding horizontal distance covered when the cannonball hits the ground, signified by y is equal to 0, and the time of flight t. Record your data in Table 3. Repeat steps 6 to 8, but in the presence of air drag. Again, record the corresponding x and t in Table 3. Provide screenshots of your simulation in the last page of this activity worksheet. At least 3 screenshots will be required in this activity. Here is a short recording of the simulation that I did in the PHY simulator for your reference. Our activity is done, and the data that you have collected will be reflected on your worksheets and will be submitted to our repository. Thank you very much for watching this video.
Okay, class, do you have questions sa video? Nakuha ninyo tong data nga dapat ipakuha? Pag-raise hand lang or answer kung walay nakakuha adto. Kaya itong balikon.
Pas-pas kay mamay. Wala kayo
Pas-pas.
na-record na dito. Time na ako na-record.
Ano to dapita? Here.
Yeah.
Wait. No.
Kanang yung centimeter ba sa height. Okay na diyan mo.
Okay, this one. Record this one as your YA. Na-share ba akong screen? Pila man na? Around 40, 41. Kamay bahala. Sa inyong gusto. In meters, take note. So if this is a meter stick, then we have, like say 40 cm. Convert it to meter. And then, nakuha na to? The different trials. Okay, this one. These are actually the X values. Sige lang class. Balik to sa, sa activity ninyo. Trial 1, trial 2, and trial 3. So these are the corresponding values na nasa meter stick banda. And then sa time, take note sa time, we have 0.34. So we have 34 seconds, 29 seconds, and 33 seconds. Hindi siya point. Paspas sa kayo yung 34. 0.34 nag-good siya. 0.34 seconds. Sorry. Am I right? Paspas na kayo, dugay ang time kung 34 seconds. So I guess this is 0.34.
Yes, ma'am. 0.34 na siya, ma'am.
Yeah. It's 0.34, 0.29, 0.33 seconds.
Okay
Nakuha?
na.
Okay?
Now
next. The second, katong mas taas gani nga elevation, YB. Again, in meters.
YB na, ma'am.
Yes, Y sub B. Done?
Done.
So, trial 1. Ibulag-bulag lang. What is the measured range for trial 1? Kani siya class, gibutangan og straight dire. Estimate. Again, in meters. And then second, 0.43 seconds. Next, trial 2. Things. Kamot mo sa mga hindi mo kakuha class na mo ikagrupo basta nakakuha sila sa data. So trial 2.
Trial 3.
This one, trial 2, and then nakuha na ba?
Yes, ma'am. 3 na, ma'am.
Okay. 3. Okay, trial 3. Ilan na ka cm? In meters, again in meter. 0.8 blank. Trial 3, 0.38 second. Okay, that's it. Done?
Balik sa atong trial 1, ma'am. Katong time, wala na record.
Sabi na, human na.
Trial 2, ma'am. Sa time lang.
Confident kayo mag-go. Okay.
Trial 2 na, ma'am.
Yes.
Lag day. Trial 3, ma'am. Time.
How about the others? Wala lang naglisod? Isa raman ako madunggan.
Okay na sa ako,
Okay na,
ma'am.
ma'am.
Okay, sige. Akong balik
Mga
to sa
naman?
kwan. Yep.
Kanang ra kay Ogbi. Sa man tong isa, ma'am? Ay, model to siya sa confirmation sa imong calculation.
You the simulation? So, may
Katong murag
explore
group
add to.
tong computer.
Okay. Sige. Can you see the activity now? Your manual? So, these
So,
equations are very useful. Okay, especially sa this is commonly used when our object is undergoing a uniformly accelerated motion. So in finding the x component for position, we have this x equals v naught cosine theta t times t, and then we have y. If along y na position, then we have v naught sine theta naught t minus 1/2 gt squared. So you unya ato ning equal asa dapit na sila theta o si v naught. And then finding the x and y components of the velocity at any time t, we have the v naught cosine theta naught, and we have v naught sine theta naught gt. Again, your g here is constant, which is 9.8 meters per second squared. Kani silang na ay sine, cosine, mga x component na sila sa velocity class. Now, you can see here that your v's of x, or ang velocity ni marble undergoing a projectile motion, is equal to the initial velocity of the marble. In this activity, the marble is undergoing a horizontal projectile motion in which its initial velocity is along the horizontal line. Okay? Therefore, yung theta niya dito is 0. I guess na siya sa next pages na yung theta naught is 0. So you have cosine 0, which is 1. So therefore, your v naught is equal to v naught x component 0. No. Theta naught is 0, so you have x component which is equal to the initial velocity v naught. And since the projectile motion, the acceleration is along the vertical axis. Diba ang acceleration always pointing downward, so therefore wala acceleration along x. Ang acceleration is naa sa taga ni class along y ra. So therefore kana ganing wala nag-change ang velocity along x. Constant lang iya ang velocity along x. So anytime t, its v sub x is equal to the x component of its velocity. Okay, initial velocity. And along y, since naaman tayo acceleration, nag-change na siya. Okay, with respect to time, since we have an acceleration along the horizontal, along the vertical. So this one, mo tong inyong nakalculate na nakuha nga data along x. Okay, katong na ay meter stick. And then katong elevation for nga YA and YB. So mo ni sila. So inyo na siyang ibutang dinhi. Okay, we have the table here. So sundan lang ni instruction, compute the time. This one is compute the time kani ata kani record these values in this table. Okay, 1/2 gt squared using this equation. And then calculate the initial velocity for both marbles. For marble B, for both YA and YB. And then taas-taas siya class, compute the velocities of this marble upon striking the floor. So you will compute v sub x and v sub y, and then ang pangitaan nga velocity is katunay yung velocity vector, which is pangitaan ninyo ang magnitude using the vx and vy, di ba? Square root of vx squared plus vy squared. And then we have theta, which is the direction, tangent inverse of vy over vx. And you must catch the direction of this velocity and label. Don't forget to label the vx and vy as well as the direction theta. Nasa procedure part B katong na ay simulation. Okay? Naadiri ang instruction class unsay gusto ipabuhat sa inyo sa simulation. Just follow this one and then don't forget the screenshots. And this one, i-record ninyo ang mga ma-observe ninyo sa simulation. Make a graph. Just follow the instruction here. And yeah,
Ma'am, naro ko clarification, ma'am.
yes.
Regarding sa screenshot, ma'am ba? Pilag ito, ma'am. 3 times, tulo, di ba, kat screenshots, ma'am? Or, isa na lang. At tulo, sige po.
Pwede ra at least 3. Like say, kaning sa 5 meters. Kaning nga mga screenshot, pwede na siguro din niya. Proof lang na siya class nga nag-work mo. At least 3, di ba itong ganyan sa video? Without air and with air drag.
Ito, ma'am.
And then, increase po ang angle. Okay? Mag-vary po ng angle o ang initial velocity mag-vary sab. Okay. We're running out of time kaya to ang Zoom. Dili preview. Any questions? Submission after 1 week. Ipasend na lang siguro ta mo open class ay Google Form katong submit. Depende na lang sa ako. And basin lahin lang inyong masubmitan sub. So, questions?
Ano sa deadline, ma'am? Saturday?
1 week after. So, Thursday.
Thursday? Sige.
Yep. Next week.
Okay.
Wait lang class. Murag mahurot na akong time. Kasi pa may gusto istorya. Pwede ta magkuan. Saman, balhin ta sa Gmeet. Or, di siguro ka nang balik ng guro ang Zoom no kung gusto pa mo magstorya. Questions class. I-send po na ko ni inyong activity. Either sa Drive or dito sa JC. Mas dali man sa JC, no? And class, if pwede, dali ang part. Kasi since taas naman ni siya na activity, please print na lang class. Print sa dili ganahan mag-computerize. Pwede naman tayo mag-computerize ka mo. Ay, naka-PDF man din eh. Pwede na po maka-edit mo ang PDF.
Excuse me, ma'am. Ang sa amo ading kagrupo mo wala siya kasulod kay kuan daw kanang hinay daw ang signal sa iyang kuanan ron, ma'am. Dili
Okay,
daw
okay. Sige lang.
Thank you,
Tuduin
ma'am.
na lang Maybell, ha?
Yes, ma'am. Amo lang siyang ingnon, ma'am.
Dali naman po ni siyang instruction as long as ma-follow lang sa instruction.
Yes, ma'am. Thank you po.
Basta as long as naan na mo atong data, dili for YA and YB. And then katong time, ibutang ninyo din niya. But of course, you will compute the time using this equation. Okay. Again, class, your G is constant. That is 9.8 meters per second squared. Then answer everything. Let's say Y marbles A and B strike the floor at the same time, like that.
Excuse me, ma'am.
Yes.
Kanang dili lang negative 9.8 meters per second squared among gamiton, ma'am.
Okay, sige. Nice question. Ang ipaggamit sa inyong equation no, is this one. Okay. Ngano ganining kanina siya class, then nahimo ra siya negative 1/2 gt squared because the initial velocity is along the horizontal, and then sign of 0 kay horizontal man, therefore walay angle. Okay, nakaana rang imong velocity. So sign of 0 is 0, so therefore this first term is 0. So you have negative 1/2 gt squared. Okay na ni siyang negative 3 class. That means your G is 9.8 na lang, positive. Kinana ang negative diri sa gawas. Napagawas na daan. Based sa kaning equation. Sa kanang equation, but sa given, diri sa equation, this one, naka-negative pa, no? Naka-negative, ay wala pa siya naka-negative.
Positive, ma'am.
Pag naka-positive ganun na siya class, you need to substitute the negative here sa 9.8.
Sige, ma'am. Thank you, ma'am. Noted po.
But basta take note that your T here should be positive. Kaya kung makakuha mo T nga negative, mali na mo class. Walay time nga negative. Questions.
Thank you,
Another
ma'am.
questions. Yes. Eh, di ba square root man naka T squared, so square root ana plus and minus. Pero I guess man negative ni siya din. Ang y po ninyo diri class is negative. Di ba? Negative. Ay positive. No. Giset man dahil ni okay. Karoon na to ni siya class. Yung y ninyo, okay, giset ninyo sa taas as y. Dili siya 0. Ang 0 ang ground. So therefore, your y reference point here is y na i-value, which is point, pila na ito? Pila tong gihatag, 0.7 ba to? 0.4. So yung g ninyo diri nga gamiton kay i-positive na diri. Kanilang kani. Dapat kabalo mo gamit sa reference gani class. Ang y gani diraa sa taas kung asa ang marble is already positive kay ang giset dira ang 0 kay ang ground. Okay, kay ang ground man. So therefore kailangan basta as long as makakuha tag time nga positive class. I guess ang positive na ng 9.8 din eh. Mo siguro nang gitanggal nila ang negative diri sa instruction. Di nato dong i-try og solve. Kung makakuha ba tag positive. 2y over g. Yeah. Tama. Okay, for clarification na lang class ha. Kanina lang na equation gamiton and then your g here is positive, 9.8. Again, positive 9.8. Para di mo makakuha time nga kuha negative. So less than a minute na ta saman. Napa may question? Or mag-share ko otro link?
Start raw ni mo.
Share na lang ko otro basi na pa may laing question. Kent, you have question? May Ann, Jasem?